Hi everyone. So I'm gonna do this circular motion question. This question is also from for the mechanics, past paper 2022 May June. I'll drop in the code in the title, so you guys can go to the question and the marking scheme. So I'll be doing this question today. So as you can see, it's 6 plus 3 plus 4. That's 13 marks in total. Yep. And they're asking us in part A show that they're asking us to show that the tension in the spring is 3 over 5 mg in brackets 5 cos theta plus 3. Okay. And then they say, they ask us to find the speed and finally they ask us the maximum height of P above the horizontal level of O. Okay. So these say in the question, particle of P of mass m is attached to one end of a light in an extensible string of length A. The other end of the string is attached to a fixed point O. The particle is held at the point A, where OA is A, and OA is horizontal as shown in the figure. The particle is projected vertically downwards with speed square root 9 ag over 5. Okay. Yeah, so they ask us to show the things. Okay, so what we can do is, so I'm going to draw a diagram. Always remember, when you get these type of questions, draw the diagram. You get marks for that too. So, label like that. So the particle is here. So tension is this way towards the center. Your mass acts directly downwards in G. They haven't mentioned it, but yeah, so it's mass N. And this is theta. So if that is theta, this is also theta. And it was released from here. So that's A. Okay, and it was released with a speed of 9 ag over 5. Okay, so they asked to show that the tension. Okay, so what you got to do first? What you got to do first is, so you need to find the speed at this point. So we call this B. No, they call, we just, okay, the particle is P, but we'll call it B, all right? So we need to find the speed at B. After finding the speed at B, we use centrifugal forces to find the tension. So let's find the speed first. So we have change in kinetic energy. So we got to use the formula for conversion of energy. Change in kinetic energy plus or minus the potential energy. So it's plus if it's going up, it's minus if it's going down. So kinetic energy and potential energy, like they're the only two energies acting on this question. You don't have friction, we don't have any sort of resistance, we don't have any of that. So you don't have to worry about that. And we don't even have a elastic potential energy because they say it's inextensible. So it remains fixed. So this equals to 0. This is the formula we're going to use. So change in kinetic energy is half into m. So the speed at b, we're taking as v. V squared minus half into m. And initially, it was 9 ag over 5 in a square root. So 9 ag over 5 squared. And it's going down, right? started here and it's going down. You can see it's going down. So it's minus m g h, right? And we got to find h. So it started here, starts here, and we need the horizontal height, right? And ends here. You can see it ends there. So if this is a, radius is a, so this distance is a cos theta. It's a cos theta because we need the horizontal height. This height, the horizontal height is needed for MGH. So the horizontal height is a cos theta. Okay? So I write half. So I can cancel off the m's. Half v squared minus half into 9ag over 5 minus g into a cos theta. That's your horizontal height. Okay, so now let's multiply everything with 2. So v squared minus 9ag over 5 minus 2g a cos theta equals to 0. Let's take everything on the other side. Half plus 9ag 5 plus 2ag cos theta. So we can take ag outside and leave it as 9 over 5 plus 2 cos theta. Okay. So we found our speed. Now, what they do is, now we're going to find the tension because they say, so the tension, I'm sorry, so the tension we're going to mark it as S because they say it's S, right? So we need to find that. So now, this using centripetal forces, so tension acts upwards, mass is downwards. So it's S minus mg, so it's along this axis. We take it along this axis. So it's S minus mg cos theta. I'm resolving it onto this axis. S minus mg cos theta equals to, and in this case we have the velocity. So we use m v squared over r. A equals v squared over r, or A equals r omega squared. We use this if they say angular velocity, but in this case we found the velocity, right? So it's v squared over r. So that's right. S equals m into, so v squared is this, ag 9 over 5 plus 2 cos theta over a plus mg. You cancel off the e, then you end up with S equals 9 over 5 mg plus 2 mg cos theta plus mg. So now you got to use your calculator because we got to add 9 over 5 and 1. Oh, I'm sorry, I think I made a mistake. So when I take mg cos theta onto this side, it becomes mg cos theta, right? Yeah, let's do the mg. I just forgot to put cos theta. Okay, so now you can add it up with S equals 9 over 5 mg plus 3 mg cos theta. Now let's take 3 outside. No, not 3. Let's take 3 over 5 outside, because I think they took 3 over 5 outside. So 3 over 5. So 3 over 5 into 3 gives you 9 over 5, right? Plus, this becomes 5 mg cos theta. Or we can take mg out too. So S equals 3 over 5 mg 5 cos theta plus 3. So for part B, they ask to show that V equals square root 3ag over 5 when the string becomes slack. So what you can do is, we know the tension, right? So this equals 3 over 5 mg. I will be 5 cos theta plus 3, right? So what you can do is, you can write S equals 0 because becomes slack, right? So then you end up with 5 cos theta plus 3 equals to 0. So cos theta equals minus 3 over 5. Can leave your answer like that. And then you can use the conversion. So minus 3 over 5. So cos inverse 3 over 5, you get the angle as 126 point, let me just check the in, 126.869. So 126.869. So theta starts from this vertical axis, right? So 126 is somewhere here, we can see. So at some point over here, I'll just write that with another color. So no answer. No, I'll take the blue. So this angle is 126.86. So we can use this angle instead, right? Is 180 minus that. So 180 minus, that would be 53 something. So the other angle, 180, subtracted by theta, is cos inverse 3 over 5. Not negative 3 over 5, 3 over 5. So we need to find the speed at this point. So you can take this as your initial, this as your initial, this as your final. So you can write half m squared minus half m square root 9ag over 5 squared. And since it's above, you can write plus mg, and the height's gonna be this this height, right? So that height is a cos, we call it beta, a cos beta, a cos beta equals 0, and cos beta is 3 over 5, right? So now I'm gonna cancel out m and multiply everything with 2. Plus 2ag cos beta is 3 over 5 equals to 0. So now v squared minus 9ag over 5 plus 6ag over 5 equals to 0. So you can see same denominator. So it's going to be v squared minus 3ag over 5, right? Equals to 0. So v equals 3ag over 5. V equals square root 3ag over 5. Or without doing it this way, we could also directly use this value. So this seemed pretty long, right, for 3 marks. So we could use this value and put it in this. So that will give you ag 9 over 5 plus 2 into minus 3 over 5, right? See, you can see you get the same odds. Yeah. That's an even better method. It saves time. I didn't notice that. So, yeah. I just noticed it now. So that's for the second part. And now let's go for the third part. I'll write it in red. Okay, so the last part, they say find the maximum height of P above the horizontal level of O at the instant when, let me just read the question again, at the instant when the string becomes slack. Okay, so top. So for part C, they ask the maximum height of P, right? Above the horizontal level of O. So what you got to do is, so now you see in the question, initially the particle was moving clockwise, right? But then in the second part, they say at the instant when the string becomes slack, the speed of P is V. Okay? So this is a weird type of question. So let's assume it's turning the other way. Let's say instead the particle started here with the same speed, with the same exact speed, then it would snap here, right? Like, well, it would like become slack over there. So these are the angles it will become slack. So when it becomes slack, we have to assume, but they haven't mentioned in the question. This question is not 100%, you know, how do I explain it? They haven't made this question in a way so the student understands it in a way. So what I think is the string snaps after it becomes slack. Because they say maximum height, right? So if it continues its circular motion, it would just have a maximum height of E, because that's the radius. So we gotta assume it snaps when the string is slack, and then after that it travels with projectile motion. And with that projectile motion, we find the highest point of projectile motion, and then we add that height with this height. Okay, so I'll draw a small diagram for that. So what I'm going to do is, let's take that point we found earlier. That angle in the previous part, remember I said it was 126. 26. And this angle is beta, right? Which was cos beta equals 3 over 5. Okay, so let's take it like that. And let's say the string snaps from there. So what is the angle over here? So what you can do is you draw another imaginary line. So this is going to be beta. This will also be beta. You can see. So that's beta. So and we know the speed. We found the speed in the previous question. So it's slack at root 3 ag over 5. So it's slack. At the point when it becomes slack, we have to assume it snaps. We have to assume the particle breaks off the string and goes above to its maximum height. So now we use projectile motion. So in projectile motion, to find the highest point, we have to consider the vertical height, right? So our y-axis. So at the highest point, vertical velocity is 0, right? So you can use v squared equals u squared plus 2as. So for, at highest point 0, so initially it's 3eg over 5 square root 3eg over 5 sine beta, because we are focusing on the vertical. Sine beta minus because when a particle is moving upwards, the acceleration is negative, right? Because it's decelerating. That's the force, the mass acts downward, so it slowly comes down, right? So it's minus 2g h. We take it as h for the maximum height. And I'm sorry, this should be squared. It's because it's u squared. Okay, so let's find sine beta. So we had cos beta equals 3 over 5. Then sine beta is 4 over 5. That's pretty guesswork because 5 squared minus 3 squared is now 16, right? So square root 16 is 4. So your opposite side is 4. 4 over 5 is sine beta. So 0 equals, so let's square it. So we have 3ag over 5 into 4 over 5 squared minus 2g h. So h equals to, you got to use your calculator for this. So I get h equals 24 over 125. You can cancel off g. 124, 125 e. This is h. But they're asking the height. Height from, right, the origin, maximum height. So that is going to be 24 over 125 e plus this height, right? This is all. This point is all. This is a cos beta. And whatever height we found for the projectile motion is h. So h plus a cos beta gives you the maximum height. So 24 over 125 a plus a cos beta. So that's 3 over 5 a. So 24 over 125 plus 3 over 5 a. So you can use your calculator again. So I get 99 over 125 equals to 0.879. This is your maximum height. So yeah, I hope you all understood. If you guys have any doubts, just drop them in the comment section. If you guys need a tutorial for circular motion and centrifugal forces, you can drop them in the comment section. So yeah, that's everything. I hope you all liked it. If you guys like my teaching, leave a like and subscribe. Thank you. Have a great